coaster in figure 6.36 starts with a velocity of 15.6 meter per second. One of the riders is a small girl of mass 35 kilograms. At points B and C, the track is circular with the radii of curvature given in the figure, and the height of the points A, B, and C are also given. The track is assumed to be frictionless. So, what are the velocity of the roller coaster at point B? So, um, this is strictly based on energy conservation. So for part A, we are going to say that the energy at A is going to be the energy at B. At A, the energy is a kinetic, which is half mv square. If we take this as the what do you call it as this one as the reference. In fact, let's not take this as the reference. Let's take ground as the reference because the height with respect to ground is given. So the ground is the reference. So we have the potential energy as mgha. Likewise, it's half mv at b whole square plus mghb. That is the height at b. So m is cancelled from both the sides. Let's just substitute the values. That will be half V is 15.6 whole square plus 9.8 times the height at point A, which is 24.1. Then we have V sub B. So V sub B is something which you have to find. And GH means 9.8 times height at B, which is given as 34.7. So all we have to do is grab our calculator and solve for VB, right? So let me just grab mine and do this. This divided by 2 plus 9.8 times to 24.1. So that's going to be 357.86, and that's going to be half v sub b square plus 9.8 times 34.7, which is coming as 340.06. If we subtract both sides by 340.06, we are getting 17.8. 17.8 is half v sub b whole square, and from here we can easily get the value of v sub b. So let's take a square root both sides, which is coming as 5.97 meter per second. So that's the value of the velocity at b. Right. They are asking now the velocity at the point C. So again, we are going to use the energy conservation. Basically the same approach, just the energies will be different. Initial energy is still half mva square plus, that is actually va, plus mgha, and that's going to be equal to half mv at c square, and the potential is zero because the at c definitely it reaches the bottom, so it's zero. So we just have to find the value of vc in this case. Let's just substitute the values. What was v was 15.6. What was G? That's 9.8. What was HA? That's 24.1. That is VC square over 2. So all we have to do is get the value of VC. I think I'm going to find this right away. Plus 2 times 9.8 times 24.1. And the square root of this value comes out as it's 26.75 meter per second. That is the velocity at C. In part C and D, they're asking the apparent weight at B and C. So basically, they're asking the normal reaction. That's where a little bit of circular motion comes in. At B, remember it is at the topmost point, and the FBD is going to look like this. So mg minus n will be the net force towards the center, which is mv square, mvb square over r. So the normal reaction is going to be mg minus mv sub b square over r, or let's call it r1 because that's the upper radius. So we just have to substitute the value. What is r1? I think that's given as 10 meters. It's already given in the figure. So that's 10 meters. So we have to use the mass as well. So let me just get the mass 1 second. Yeah, so the mass is 35 kilograms. So that's 35 times g minus 35 times velocity at b square. And what was the velocity at b? That was 5.97. So that's going to be 5.97 square over r, which is 10. So let me just grab my calculator and find this up. That's 5.97 square over 10, and 9.8 minus this value times 35 comes out as 218.27. In fact, 27, that's 26 Newton. So that is the apparent weight at B, at this topmost point. And likewise, the apparent weight at the downmost point, again, we are going to use the same kind of method, but this time the normal reaction will be on the top and weight would be at the bottom. So N minus mg will be mv square over r. So this time it's going to be additive in nature. So 35 times 9.8 plus 35 times velocity at the point of C. I think we already found that that's 26.75. So that's 26.75 square over the value of 10. So this value is coming as 35 times 9.8 plus 35 times 26.75 square over 10. So this value is coming as, let me just grab my calculator. One second, that's 26.75 square, and that should be multiplied with 35. That should be divided with 10, and should be with 35 times 9.8. So this is coming as a big number. That's coming as 2847.47 Newton. So that is the apparent weight at the bottommost point. Thank you.